Okay, since we're getting ready to talk about weak acid, strong base, and strong acid, weak base titrations, I didn't think it would be a bad idea to just kind of revisit what happens when that. So we're going to let HA be any weak acid. Okay, so when we take a weak acid and we react it with a strong base, like a hydroxide, okay, that is going to give us A minus and water. Okay, now A minus is the conjugate to our weak acid. So if you remember we were talking about acid-base chemistry, you've got your acid here, and then you've got your base. And your conjugates are always going to be in the product side, and they're going to differ from your reactants by 1 hydrogen. So this right here, okay, this is your conjugate, if I can write today. Okay, so this is the acid, so this is the conjugate base to that acid, right? And then hydroxide, this is a strong acid, or a strong base, and its conjugate is going to be water. And because this is a base, water is going to act as an acid. Now remember that water is amphoteric, so it can act as an acid or a base. And so that can confuse people a little bit, but you can use water in a whole bunch of different ways. So this is just a very important thing to review and remember. And think about when we're doing these next concentrations and these next calculations with this, when you've got a weak acid and a strong base, just after your equivalence point, okay, if you have your weak acid and you're titrating it at your equivalence point, you have used up all of your OH negative, right? Or you've used all of this up. And what you're left is your conjugates. You're left with your conjugates here. And if we had a solution of just A minus, well, that's a base. It's a very weak base. So it's going to have a basic pH. So I did just want to throw that out there, and we will illustrate this a little bit more in some of the reactions that we're getting ready to look at. All right, guys, we are going to throw things all the way back to Gen Chem with this image, okay? I am certain that you guys recognize a titration curve graphed out. If you don't, I'm sorry, but you should be familiar with this shape. Okay, so you've got pH on your y-axis, milliliters added of whatever it is. In this case, we started with an acid, so we're adding a base. Now there's a couple points on here that you should be aware of. The first one, I'll start off right down here with this little circle right here. This is equivalence point. The equivalence points are kind of where your graph starts to curve. And this is how you can figure out where your equilibrium point is just by looking at a graph. So you've got one on the bottom where it starts to curve up, and then one at the top where it starts to flatten out. You take those two values and you divide them in half, and that's going to give you your equilibrium point. Now, so here's your calculation on that. The other one is when you take your equilibrium value and you divided that by 2, that's going to give you your half equilibrium point, which is this little guy right here. Now, a very special thing happens at your half equivalence point, and that is at your half equivalence point, your pH is equal to your pKa. So that is something that we will need to remember for this section, because that is going to come back and be part of all of the things. So just a quick refresher on what a graphed titration curve looks like. Eventually we'll get into doing gram plots and stuff like that in Excel, and it's going to be all sorts of fun. See you later.